Hi grade 11s. So today you're going to be working on some more titration practice problems. You had your lesson earlier this week and you practiced it again yesterday on gizmos. We're going to do a little bit more practicing doing the problems together. You do have this worksheet. There are 6 questions attached. We're going to do the first 2 together, and then the rest of your time is going to be spent completing the other 4. Okay, so it should be pretty quick once you get started. But we'll do 2 more together just to make sure we're all on the same page. Okay, so I'm going to make myself disappear here, and we'll get started on these first 2. So if you remember, we did say when we first learned about titrations that there's 3 main steps that you're going to follow. The first one is you're always going to figure out your moles of your known, okay, using N equals C times V. Your second step is always going to be to figure out your moles of your unknown. Okay, and to do this, you're going to use your mole ratios. And your last step is always going to be to figure out your concentration of your unknown. And that's going to be using C is N over V. Okay, if you follow those 3 steps, you should be able to figure out all of the solutions to these titration problems. Okay, so first question says, if it takes 54 milliliters of 0.1 molar NaOH to neutralize 125 mils of an HCl solution, what's the concentration of the HCl? So what they're saying is, like we've seen before, you have your burette set up. You have your Erlenmeyer flask, okay? In your burette, you have NaOH. We know for a fact, because it's a standard solution likely, it's 0.1 moles per liter. And to turn the acid from clear to pink, we needed to use 125 milliliters. That's given to us in the question here. We do know the acid that we're dealing with is hydrochloric acid. We don't know the concentration. Oops, sorry. We didn't use 125 mils of the base. We used 54 mils of the base. That's why it's important to read the question carefully. And we have 125 mils of the acid. We're trying to figure out what this concentration is. Okay? So first thing I'm going to do, what do I know my information about? Well, I know my information about NaOH. That's what's in the burette. I know it because I have the concentration and the volume. Okay? So moles is always concentration times volume. Concentration given to me in the question, 0.1. And the volume, 0.1 moles per liter. And the volume was 54 milliliters, so 0.054 liters. Okay? That's going to give me 5.4 times 10 to the negative 3 moles. So I've done my first step, which is figuring out my moles of my known. Now what I'm going to do is I'm going to figure out my moles of my unknown. Okay, to do that, so this was my first step. To do that, I need to know my balanced chemical equation. So I know sodium hydroxide is going to mix with hydrochloric acid. It's going to make sodium chloride and water. If we look, lucky for us, this equation's already balanced. 1 sodium, 1 sodium, 1 chlorine, 1 chlorine, 2 hydrogen, 2 hydrogen, 1 oxygen. So it's a 1-to-1 mole ratio. Okay, so my moles of my unknown, which is in this case HCl, is going to be my moles of my known times my mole ratios, which we are lucky is 1-to-1. 1/1. So it's going to be the same thing. 5.4 times 10 to the negative 3 moles. So my third step is going to be figuring out my concentration of my unknown. And my unknown in this case, again, is my hydrochloric acid. I'm going to calculate that with moles over volume. I just figured out my moles, 5.4 times 10 to the negative 3 moles. And it's in 125 milliliters, which we know we have to convert to liters. Which should give us, and again, we're going to report this to one significant figure. 54 has 2, 0.1 has 1, 125 has 3. So we're going to convert that to 0.04 moles per liter. Okay, or you could also do this as 4 times 10 to the -2, again, mol per L, or in square brackets, they're all the same, okay? But essentially what we're saying is the concentration of this acid must have been 0.04 moles per liter, okay? So just follow those same 3 steps. Now let's do that one more time. So we said first thing, moles of our known, using N equals C times V. Then we're going to figure out moles of our unknown using our mole ratios, and then we're going to finish off with concentration of our unknown, which is going to be calculated using C is N over V. Same 3 steps for any titration. Okay, so this time it says, oops, don't need that. If it takes 25 mils of 0.05 moles per liter HCl to neutralize 345 mils of an NaOH solution, what's the concentration of the NaOH? So this one's a little different, that the bases are unknown. So this time we would have our HCl up in our burette. Okay, the HCl we know is 0.05 moles per liter. And when we measure it, it required 25 mils to neutralize our 345 mils of NaOH. But we don't know the concentration here. Okay? So it's a little different. The base is in the bottom now, but it's our unknown. That's why. So the first thing I need to do is figure out my moles of my known, which in this case is HCl. So moles of my HCl is going to be concentration times volume. Concentration is 0.05 moles per liter. That's given to me in the question. My volume, again, we have to convert it into liters. It's going to be 0.025 liters. So that's going to give us 1.25 times 10 to the -3 moles. That's our first step. Our second step, we need to convert it. So we need our balanced chemical equation. This is the same chemical equation as before. We just used it. And luckily for us, it's a 1-to-1 mole ratio. So it's going to be the same. I'll still show my work so my teacher knows where I'm getting it from. So I'm converting using my mole ratios. Okay, so 1.25 times 10 to the -3. It's 1 NaOH for 1 HCl, which is going to give me the same number. Okay. And now that I know the number of moles of NaOH that reacted, I can figure out my concentration of my NaOH. Concentration is moles over volume. I just figured out my number of moles. My question told me how much volume I had. I'm going to convert that to liters. It's 345 milliliters, or 0.345 liters. And again, 25 has 2 sig figs, 0.05 has 1, and 345 has 3. So I'm going to report this as just 4 times 10 to the -3 moles per liter. I could also write this as 4 times 10 to the -3 moles per liter, or I could put it in square brackets. Okay, all the same thing. So we've done 2 more questions together, okay? And you do have examples from the lesson that we posted at the beginning of the week, lesson 4. With that, you should be able to answer these next 4 questions here: question 3, question 4, question 5, and question 6. Okay? Hopefully everyone's staying safe, staying at home, and staying healthy. Looking forward to hopefully seeing you guys soon.